we have with us one of the epidemiologists at the forefront of this field of research, who works through a multidisciplinary approach called One Health, which combines human, animal, and ecological health sciences to tackle zoonotic viral threats. So welcome Dr. Jonna Mazet, who is one of the most renowned leaders of the One Health movement. For the past decade, she served as the global director of the $200 million epidemiological research project called PREDICT, which discovered more than 100 new coronaviruses. And now she sits on the board of directors of the Global Virome Project, which is one of the most preeminent global initiatives for emerging infectious disease prevention, which will run for the next 10 years and seeks to identify all potential zoonotic viruses. In 2013, she was elected into the U.S. National Academy of Medicine, and she teaches at the University of California, Davis. So I could go on about her accomplishments in this field, but we're all here to hear from her. So Jonna, let's just jump in. What are your predictions about a next pandemic? When will it come? Where will it come from? What type of virus can we expect to see? Oh, I'll stop you 1 sec. I think you're muted.
Uh-oh.
Okay, there we go. Perfect.
Well, I wasn't, but okay. Well, anyway, I just wanted to thank you for having me and the audience for this great forum. And the bottom line, to answer your question, is that we don't know. And I think that's super important. It's important to recognize that there is so much yet to be discovered, and that if we don't get busy doing that, finding those viruses and understanding the transmission risks and the circumstances in which they occur, we can't modify our behavior to protect ourselves from getting them. So if we want to make predictions, we certainly have a lot of information about what's happening in the world that is driving the transmission and the spillover of these new viruses into people. And that has a lot to do with how we use the planet. But we won't know what the next one is until it hits us, unless we get prepared and find out about those viruses and mitigate our risk. I think you're muted now. Oh, there you go.
Okay. I'm not sure.
Someone's unmuting us, but it's not me anymore.
Probably to protect the sound, but hopefully it will be better now. So this is exactly what the Global Virome Project seeks to do, and it wants to create a comprehensive database of all potential zoonotic viral threats, which is a very big goal. So how long would it take to create such a database, and what kind of defense or offense would it give us against pandemics if we have such a database?
Great. So as you mentioned, thank you for that very kind introduction. As you mentioned, I did have the honor of running the PREDICT project, which was funded by the U.S. Agency for International Development. And it worked in some of the most vulnerable places in the world for this spillover risk. And those places include places where the human population growth is just burgeoning, and we have a lot of biodiversity, and we're changing the way we use the land. So landscape change is a critical factor. What we learned by doing that is we can understand how many viruses, how many samples we have to take to find the viruses in their hosts. So for example, for this terrible pandemic that we're all enduring right now, we weren't working in the part of China where the first spillover likely occurred, but we were working in other places in the world and understanding where these types of SARS-related coronaviruses come from and what species they come from. So we know exactly how many samples we need to test until we kind of flatten the curve. I know we talk about flattening the curve a little bit differently, but so that we flatten the curve and say, wow, we've saturated our discovery. We found all the viruses in that species. And when we do that, we get a really good idea of all the virus that's available to transmit to us. And then we can rank them and understand their risk. So we know how much that would cost if we look at every potential host species in the world. And we know that if a global coalition comes together and countries work on their own country and contribute to that database, we can achieve that knowledge base that will help us identify all the circumstances, prevent the spillovers is ideally the goal. But in addition, it tells us the distribution, where these risks are occurring, how we might protect ourselves, and gives us a rich viral catalog from which the virologist can work to identify targets for vaccines, how we do diagnostics, get all of those pipelines prepared in advance so that we're not chasing after it as we have been on this one.
Mm-hmm. It would be an incredible comprehensive resource. And the Global Virome Project has estimated that it would take about US $4 billion to fund such an effort. How is it going raising this money, and why is it difficult to raise what seems like pennies to prevent future pandemics?
Yeah, and frankly, we could find almost all of the really risky ones for about 1 billion. So if you put that into context of understanding that before the SARS-CoV-2 pandemic, we were spending on the order of about $40 billion every time we responded to a large outbreak. So we, of course, think about MERS and SARS and H1N1 influenza and the terrible West Africa Ebola outbreak. So that we were really thinking about, we're talking about less than 10% of a single outbreak spread over 10 years with countries working together. Now we're talking in the trillions. Before we get done, we might get up to $40 trillion that the world has lost, not to mention the devastating lives lost, right? So it's less than 0.01%. To actually find the viruses in advance. Why it's hard to raise that money is because the way our political systems work, we deal with what's right in front of us right now or what just happened to us. It's human nature to deal with those things rather than to look forward and say, well, let's get ahead of this one. And I think that's likely to change now. And we've already seen huge amount of resources going to many different budgets around the world. And to be clear, we're not saying we need not the board of the GVP doesn't need to hold those funds or raise those funds. Those are just funds that countries, if all the countries collaborated and those countries that didn't have the resources help out their neighbors as USAID does from the US's perspective, that's about what it would cost to do it in a finite timeline.
Mm-hmm. And what does this research project process actually look like on the ground? What does it entail to identify potential emerging infectious diseases?
Yeah, again, luckily we had this $200 million investment that has developed all the standard operating procedures, translated those into many different languages, and road tested them in 35 countries around the world. So in the PREDICT project, we were only able to look at bats, non-human primates, and rodents, and then people. And what we need to do with the Global Virome Project is expand the countries, the interfaces, and expand it to all the potential wildlife hosts. What that takes is a trained, safe workforce, people who are really good with PPE and biosafety and biosecurity, working in their ecosystems, identifying the high-risk transmission interfaces, taking lots of samples. We took almost 160,000 individual animals and people were sampled in the PREDICT project to do the proof of concept, to even know if we could do this and figure out how to do it and the cost. Once you get those samples, you need to have laboratories that are ready, willing, and able, and we have all the laboratory protocols, so we know that can be in the least resource labs in the world can do this work now because of technological advancements and the pre-work that's been done. So then you have to get in and detect and discover virus. And it's not just discovering the ones that we don't know yet that are new to science, but it's also understanding where those bad actors are. And so, for example, in PREDICT, Marburg virus causes deadly outbreaks primarily in East Africa. We found it in West Africa. So the clinicians in West Africa, just like with Ebola for the 3 most devastated countries for the outbreak, haven't been looking for Marburg. Now they're looking for Ebola, but the outbreak got so out of control because they weren't looking for Ebola. So this project also will allow that risk to all be characterized. And another important thing is when we understand the hosts that we find these viruses in, we don't necessarily have to find the virus in every landscape because we can look at the host range, the home range for those hosts and figure out where risk is. And we've done that obviously already, knowing that SARS-related coronaviruses are primarily in rhinophilid and hippocytarid bats. We can overlay that home range of those bats and know that actually it's not just China, it's also most of Southeast Asia and part of South Asia that probably have regular small spillovers that don't turn into terrible disease of these SARS-related coronaviruses. So there's a lot to be done, but the great thing is we know it's doable. It's completely feasible.
Oh, that's amazing. And you're talking a lot about species and landscapes and habitats. And to switch gears just a little bit, we're entering into a new decade and a new decade for climate and environmental protection policy on the global scale as well. The post-2020 frameworks are coming up on numerous ends. So how do you hope the research that you're doing feeds into environmental protection policies, global frameworks, et cetera?
Yeah, it's critical because I want to emphasize that viruses that cause these deadly diseases and terrible epidemics and pandemics, they aren't out there lurking, just waiting and jumping into us, right? It is actually humans, our behavior and how we treat the earth that puts us at risk. So the drivers that are causing all of the environmental damage are the same ones and are synergistic with the environmental problems we see. So we really need to use the One Health approach, as you, thank you for in the introduction mentioning that. That's where we take the brightest minds working in different disciplines, coming together and thinking about this. So we need to think about environmental engineers. We need to think about the agricultural sector. We need to think about how we use the planet, because it is how we push and shape. Unfortunately, humans are really influential on our landscapes, and that causes big problems, including for disease. In fact, I think that disease is one of the most time relevant aspects we can see with climate change. We've been able to document viruses that never were in the Pacific Ocean and wildlife in the Pacific Ocean coming across as the polar ice cap melts and infecting animals in the Pacific Ocean. So we're seeing health impacts from climate change and climate variability right now. And I think that's something we can use to bring home to people that these impacts are not just generations away, they're happening now.
Mm-hmm. Yeah, it's real-time feedback. And I think people are starting to wake up to that a little bit, but probably not enough. So taking it back just a little bit, there's plenty of research happening on coronaviruses shortly before COVID-19 broke out, including the work of PREDICT and other programs. So we were in reach of it feasibly never happening. How did the research community react when it nevertheless did break out? So
I might just quibble with you a tiny bit on plenty. I don't think there was plenty of research. Obviously, we needed much, much more. And we needed the global coalition, like I'm describing for the Global Virome Project, where every country is participating, or all that can are participating, because it's not enough to just work in the laboratory on a coronavirus that came out before. And that's the majority of what had been happening. Certainly, our PREDICT project and a few other smaller projects were looking for coronaviruses, trying to find them in advance and contributing those viruses to the scientific community so that others could work on them and try to understand them better and come up with treatments. Like remdesivir was tested on some of the coronaviruses that we found. Novel vaccine pipelines were tested on other viruses, not coronaviruses, unfortunately, but were tested on some of the filoviruses that we found. So that was just starting, but frankly, it was kind of like the wild, crazy fun things that researchers were doing, not our core team, but a lot of people saw it as an aside, like, wouldn't this be interesting? Let's work on this as it wasn't a well-funded area. And so a couple of things happened during the pandemic. One is people got interested again in coronaviruses. So there was a lot of interest back when the first SARS happened, which thankfully didn't turn into this one the way that we're dealing with now. But as I mentioned, that faded, right? People's interest fades over time. We can't let that happen again. So the people that had been working in coronaviruses immediately started working together in ways that I've never seen the scientific community come together in the past. People set aside differences or worries about credit and work together in a really beautiful way, frankly, because we recognize that the human population as a whole, as a globe, was facing something terrible. That said, there were very quickly political impediments to that collaboration. And I think scientists, like people I work with, have been fighting those political impediments and working hard to try and maintain our collaborative relationships. But there have been a lot of challenges with that because of political will, because of kind of nationalism, people not wanting to be blamed or whatever, throwing up barriers. So I hope we can overcome those.
Mm-hmm. And you've talked a lot about the need for international collaboration to put together such a database and to do such research. Meanwhile, we have seen a lot of nationalism and borders closing and political squabbles go on throughout this pandemic. So what would you like to see happen at the international stage? What kind of platform or new initiatives, or what would you like to see more of that's already ongoing to bring the international community together to research and fight pandemics?
Well, I think first and foremost, we need the political will to make a huge effort for our citizens to trust science. So I think it's easy when things aren't going well, intensive care units are filling up again and people will say, well, the science hasn't helped us or something like that. And really the science and the scientists have been trying to help, but we need the leaders to work together with the scientists and really support the scientists so that we can have really strongly evidence-based solutions when we get into this terrible tragedy, but also preventive solutions. And so I think it's the scientists need to speak more and speak clearer and better with other communities, including the policymakers. And then we need to see the policymakers come together. I do think we need the international collaborative organizations. I know that it's probably, the WHO is really one of the flashpoints for this discussion, and we all need to be supportive of the WHO. But we also can do initiatives, as have happened, that are supported by WHO, but are independent coalitions, like we're trying to build with the GVP.
Mm-hmm. Okay, I'll ask one more question and then we'll go to questions from the audience.
Okay.
So anyone who's listening, if you have questions, please ask them in the question box. But a lot of our audience here at the Global Landscapes Forum is young professionals and people coming up in their careers in these fields: ecological, planetary health, human health. What advice would you give to young professionals entering fields of health right now?
Yeah, that's a great one, and thank you for that. And I should just mention that right now my primary effort is in the workforce development. So we have a new U.S. Agency for International Development project called the One Health Workforce Next Generation, and we're working with more than 100 faculties as well as ministries. Again, not in the US, but in partner countries for USAID, to build a strong and collaborative workforce across multiple disciplines. So my first and foremost piece of advice is build yourself a cadre or a cohort of colleagues that are different from you. It's great to have colleagues that are in your same area, and it's easier to build those because you tend to train with them or then go on to be in a position or a workforce with people like yourselves. Spread out and find colleagues that are different from you, that have different knowledge bases that you can collaborate with. I think that's first and foremost. Secondly, is I think we really need to be thinking about inequities. A lot of what has driven this spillovers throughout history, as well as the problems that occur after a pathogen spills over, or in all other sort of landscape areas, is that we really don't work together. And we try to solve it with the knowledge in our heads or inside our discipline. And we really need to cross the aisle and think about how these, all the different parts of the planet work together. So I think that those are two really important things that we all can do. And it's also fun and enriching for your personal and professional career.
Great, thank you. So here's a question from the audience. What are the main difficulties for the scientific community when trying to collaborate with governments on disease prevention?
I don't think that we have a problem collaborating when there's not a tragedy. I think the obstacles come when there wasn't a good enough plan ahead of the tragedy. So the scientists might sit and make their plan. The government might make a separate plan. They're not always informing each other, though we do better at that time point. And that's what I'm really advocating for, is that we get together and we work on the pre-plan. And so that there is a good evidence-based plan that can be adaptively managed once a tragedy starts. What happens once a tragedy starts is often the political and economic sides come into it, which they always will. And sometimes that can dampen down the science side and override the science side. And that, I think, is the big mistake that was made, especially in countries that are suffering the worst, including my own. And I'm sorry, I kind of lost my train on the last one about inequities, but inequities are really, where people have less of everything: nutrition, access to healthcare, access to education, all of those things is where we see the biggest problems, and people living in close proximity to things like deadly pathogens and not being able to interact with the scientific community and their policymakers. They have less access to us. So I really think community engagement is another key point. Understanding what kinds of actions and interventions are going to be accepted and feasible with our communities is critical.
Mm-hmm. So another question, a bit related, is what's the difference between research initiatives happening in the global north versus the global south? How are the two regions working together and collaborating on this, or not?
Well, I work mostly, I guess, and they're not all south of the border, but philosophically, I understand the question as the philosophical global south. I work mostly in those areas. I do consult and do things in North America and Europe, but I will say that I think North America and Europe, frankly, are behind. And that might be surprising to many, but I think that philosophically lower and middle income countries that tend to be in the tropics are actually much more aware of zoonotic diseases, or those things that can transmit between people and animals, as well as the points that I made about inequities and difficulties in getting access to healthcare and having strong health systems. So I think they're ahead in their thinking and planning, not necessarily in their resourced ability to respond, but I think we need to be listening and learning much more, as I have benefited so much from my colleagues in the LMICs and the learning there. And I think, again, we haven't been focused on those kinds of problems in the global north. We think we're protected, we're safe, we're in some sort of clean environment. It's time that everyone realize we're one global community.
Mm-hmm. Absolutely. Another question is about funding and raising funding. Do you expect to see any coming from private finance or business, or is it mainly public funds that are sought after to seek this sort of research?
Well, I would hope so. And we certainly have been in discussions with major entities and groups like CEPI and the Global Virome Project. We support each other. We're working also with the big Trinity Challenge coming out of the UK for this area. So we're seeing the private citizens and the private sector getting more involved and wanting to do the global good, but also wanting to find their niche where they can really provide the most support, not just financial, but also technological and others. So I'm feeling optimistic about that. But I think that philanthropy has still been kind of focused on the world's existing problems, which is very good and super important. But we need to be, if we're really going to save the planet from a landscape perspective, including diseases that affect people and animals, I think we need to be thinking more proactive. And that's a harder hill to go up.
Mm-hmm. Absolutely. And speaking of landscapes, one of our listeners is asking about how the intensification of zoonoses is related to agricultural landscapes and specifically industrial farming, food production, animal agriculture. How do we deal with that?
Well, it's a great question. I can give you a couple of examples. One is, we know that when animals are in high density, just like people in high densities in urban areas, we have the likelihood of amplifying disease, right? So if we're in just purely by contact, you know that disease can be transmitted more easily because they're more effective contacts. But it's above and beyond that. It's the stress of close quarters, the stress of being forced together that really changes our systems. So our immune systems and other systems react and make us, interestingly, both more susceptible to disease and also more likely to shed organisms, our microbiota, that may be pathogenic to other susceptibles. So people with weakened immune systems, other species that may be naive. So there is certainly an issue around intensification of people and animals in any circumstances. Now, that said, and we saw that with coronaviruses in the human food value chain. Actually, rodents are trapped and then farmed in Southeast Asia, and we found that rodents in the wild, from where they were sourcing and trapping in Southeast Asia, these rodents, they had about 20% had coronaviruses. By the time they got to a large market, they were up to the 30 percentile range and starting to increase. And sadly, we found the highest prevalence of coronaviruses were in restaurants where those rodents were cooked and fed to customers. So we can see that along that human food value chain. Now, though, if we go out and we sample these interfaces, the places in the landscapes that we find the most virus circulating is where landscapes are being altered actively. So it's not just that we have a new huge farm. It's the act of changing the landscape from what was potentially more pristine into that farming situation. So we find it's a little paradoxical for some scientists that we sometimes find a lot less virus in the more pristine biodiverse areas, because we all have our microbiota, we just may not be stressed enough to be shedding it. But when you start to alter those systems, which is kind of at that buffer between the very pristine and urban or the most converted landscapes, it's in the middle where the landscapes are actually being changed that we see the most danger of spillover risk.
Mm-hmm. Great. And then our last question for the day is, you talked before about how we need to keep awareness up, and as people get vaccinated and are so eager to go back to normal lives again, what changes would you like to see maintained to help keep people safe, prevent future pandemics?
Well, first and foremost, I think we just need to think more proactively and be better prepared. We need the government systems, the science, just like you so nicely mentioned, need to work together. The government systems again, I'll use the global north philosophically, tend to have very siloed systems. And so one group is not speaking to the other, even within a government. And that caused a lot of trouble where in some low and middle income countries, they were much more nimble and working together and are seeing better outcomes. So moving forward, I think we need to really think about how our systems are structured and work on the collaboration. And again, if the young professionals in the audience can start that from the beginning of their career, being collaborative and working across disciplinary lines, it will help a lot. On top of that, I think that we need to learn from the silver linings of this terrible situation. We're all missing each other, missing human contact, but there are a lot of things we can learn about protecting ourselves and protecting the planet. We don't need to, before this happened, I was traveling about half of the time internationally. I knew, I guess, that I didn't necessarily need to do that, but the world and society was not used to or accepting of working the way you and I are talking today. I think we still there's never going to be a replacement from that personal contact and the trust that you build when you're with people and see each other regularly. But we also need to live more gently on this earth, and that includes how we move about. So from commuting and employers now saying, hey, maybe I don't need an office building, people can work from home and we can support them to do that, to people like me who are traveling all over the world using jet fuel, but also potentially super spreaders for these kinds of things. We need to think about how we do commerce, how we do science, how we do everything, and reduce our footprint on the planet and be more gentle.
Mm-hmm. Living more gently. I think that's a beautiful message. Jonna, thank you so much for your time and all of your insights. You've been so informative, and this was such a pleasure talking to you. We are so lucky to have you on GLF Live.
I'm so happy you guys are doing all the great work that you're doing. Thank you so much for having me.
Sure. And to everyone listening, our next GLF Live is next Wednesday with the director of a documentary called Gather, which is screening on the GLF website if you wish to watch it this weekend. And the director will be speaking on the film's subject, which is Indigenous food sovereignty. So Indigenous peoples reclaiming their natural food systems and what that means for the global food supply. So we hope you join us for that one next Wednesday. Thank you again, Jonna, and wishing everyone a good day and good night.
Thanks. Bye.
Bye.